Now let's take a look at two popular styles of dip switches and learn how to interface them to the MXP and MSP connectors. Here we have the two dip switches that are included with the myRIO starter kit. We have our standard inline dip switch on the left, and over here we have our rotary version. And as I say, both of these are included in the myRIO starter kit. DIP, or DIP, is an abbreviation for dual inline package. And that means that all of the pins on the device are set at 0.1 inch spacing, 1/10 of an inch. And it also tells us that it fits on a standard breadboard. Now let's look a little bit more detail at the standard dip switch and how to interface it to myRIO. We have 8 single-pole, single-throw switches arranged in a row. Each SPST switch has its 2 terminals on opposite sides of the switch. For example, here's switch number 1. The switch is closed when it's in the up position. On this particular model, it's labeled as on when the switch is up. Let's begin by interfacing the dip switch to the MXP connector, which would be connectors A and B. In particular, I'd like to be able to interpret the switch pattern as a numerical value, more specifically as an integer with the LSB on the right side, that is least significant bit, and most significant bit on the left side. I'm going to connect switch 8 to the least significant bit side of my digital inputs. This is DIO 0. Now, when we are using connectors A and B, which are of the MXP variety, each one of these DIO lines has an internal pull-up resistor of approximately 40 kiloohms up to 3.3 volts. Now, the internal pull-up works like this. If the switch is open, there's no current here. There's no current actually going into the eventual FPGA input pad. That means that since we have 0 current on those 2 branches, we would also have 0 current through the pull-up resistor. 0 current through it means we've got 0 volts across, and that means that the line then is essentially tugged up to the high value of 3.3 volts. Now, if we ground the other side of the switch, then when you close that switch, you produce a nice direct connection to ground, and that causes the software to see a low value instead of a high value. So that's the general idea. This means that our switches would be perceived as active low switches as far as the software is concerned. Now let me duplicate that all the way up to the most significant bit up here at DIO 7 and make the same connection to the remaining 7 switches. Now, when we switch to the MSP connector, that's connector C, I have a little bit different consideration here because now each line has a pull down resistor to ground. Pull down is the same value, approximately 40 kiloohms. And that means that instead of grounding the other side of the switch, we need to connect that up to 5 volts. You could use 3.3 volts on the MXP side, but I'm assuming we want to use the same connector side, which only has 5 volts. That means that all of these switches now are active high switches when we use connector C. Now you might be wondering about the 5 volts a little bit to realize that the DIOs produce 3.3 volts in the high state when they are outputs, but as inputs they are tolerant of up to 5 volts. Alright, now let's take a closer look at the rotary dip switch. Here's a close-up of the top of the switch. You'll notice that it has 6 pins total. and you can use a screwdriver or similar device to turn the knob on the switch. Note the corner cutout for orientation. The two sender pins are labeled C for common. The remaining pins are labeled 1, 2, 4, and 8. And these are references to the binary weights of these switches. Internally, we have 4 switches all joined together to the common. And you can use either side. Those are both connected to the same thing. Then the remaining 4 terminals, 1, 4, 2, and 8, are associated with the other side of the switches. Now in position 0, as I show here with the arrow pointing up, all 4 switches are open. When you move the selector to position number 1, that closes this first switch. If you advance to position number 2, that closes this switch and opens switch number 1. Let's try one more. Advance it to position 3. Now both switches are closed. And the point again is to operate the switches in such a way that it looks like a standard binary sequence. That is, as we look at all positions ranging from 0 to F, as we look at the switches numbered 8, 4, 2, and 1, you notice that they're open and close in an ascending binary sequence, where switch number 1 would be our least significant bit. That's the one that opens and closes on every turn. Connecting those then to DIOs 0 through 3 is the easiest way to go. If you're using the MXP port, connect the common to ground. Otherwise, if you're using the MSP port, you want to connect common to 5 volts.